Bonjour, welcome to Wahsa Lesson Education Center's radio Zoom classes. This is SVN3E, grade 11 workplace science, and I'm the teacher, Bronwyn Slade. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View, channel 972. You're always welcome to join me live through the Zoom link, which is available from me, your teacher, and also your DEC. Our classes are scheduled Monday through Thursday from 10 till 11 in the morning, and we are wrapping up our first week of our 9-week course. A reminder of what you should be planning to submit once you get to that point. The key questions are marked with a key icon and are listed at the end of each of your IL lessons, and these are to be submitted to be graded. So please do all of the questions. Some of them are check your understanding questions, some of them are activities, and the rest are review questions from your workbook. So make sure that you're doing all of them, showing all of your work, giving me complete sentences, explaining all of your thinking and your steps of how you got there. And make sure you're actually answering the question opposed to just talking about the topic. You are welcome to do this by hand or electronically. Feel free to write in your workbook, though the space is small and I don't really encourage it, but it is your book to keep. So if you want to make notes, you can totally write in your workbook. If you're going to do it electronically, Word and Google Docs are the files that are easiest for me to open. Everyone has access to Google Docs through their NNEC email address. If that is something that you're not sure how to access, let me know and I can walk you through it to support it. If you're going to use a different file type, I'm sure it's fine. Just let me know so that we can make sure I can open your files after you submit them. Okay, so then how do you actually submit your work? So the first method is to scan and send your work electronically. So if you are doing that by hand, then you can scan once your work is completed using an Apple device. The Notes app has scan function, and if you're using an Android device, the Google Drive app has a scan function. Both these apps come with the devices and are free and are fairly straightforward to use. I'm happy to walk you through it if you need that support. Then you can send it to me through email to studentwork@nnec.on.ca and CC it to Bronwyn Slade at nnec.on.ca, or you can also send it to me through Facebook Messenger, where I can get it there as well. If you need to take pictures of it, that's totally fine. Scanning just means that we get your work is a little bit easier to receive and send, but pictures are fine too. The second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at our 74 Front Street location. We're the bright red building next to the post office, and we have a small white mailbox next to our side entrance. We are not yet open to the public, but you can put your work in there and I will get it back to you as soon as I can. The third method is to hand your work into your DEC. So your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. You can connect with me through social media. Both my Facebook and my YouTube channel are under the name B Slate Wahsa. If you friend me on Facebook and subscribe to my YouTube channel, then you'll get notifications every time I upload one of our class videos. I record all of our radio Zoom classes and I post them to YouTube under a playlist called SVN3E, and then I share them on Facebook. So you can then go back and rewatch things and slow things down if you need to, or go back to parts. It's a really good way to access all of our information. Science is a really visual subject. I try to incorporate as many videos and diagrams, charts, graphs as I can to really connect all of our understanding. So I strongly suggest that you access the videos. If you don't have reliable internet and you can't access Zoom, or you can't access YouTube, let me know. Then I can send you a copy of the recordings and you can watch them on your own time without the internet needed. If you have any questions or concerns, please reach out and contact me. My email address is bronwyn.slate@nnec.on.ca. That's spelled BRONWYN.SLATE. My Facebook is B Slate Wahsa. You can call me at the office at 807-737-1488, extension 2209, or toll free at 1-800-667-3703. My office hours are Monday through Friday, 8 a.m. to 2 p.m., though I teach from 9 to 11 in the morning, so I'm not available during that time. But if you leave me a message, then I can get back to you as soon as I'm available. All right, I'd like to share my positionality in this course to recognize how my experience of education has shaped the way that I teach. So I have white settler ancestry, I have white privilege, and this means that the way that I walk in education and experience education is much easier than many folks. I can't change that, but I can recognize it and work to disrupt that cycle where white privilege significantly impacts the education experience of individuals, and those without white privilege, how it impacts their education experience. I do live in Northwestern Ontario on the traditional territories of the Anishinaabe people and work hard to acknowledge and learn from this culture around me. As an educator, I do have lots to learn and unlearn. It is not something I have all figured out. I probably never will. It's a lifelong journey, but I'm committed to continuing to work hard on anti-racist policies and practices and integrate other perspectives beyond my own white perspective into the way that I teach. Our textbook, I have found, is very Eurocentric, so it really positions scientists and communities of white heritage as the only experience. It definitely ignores Indigenous, Inuit, Métis knowledges as well as experiences, and I find that very problematic. I work to include these in my course as much as I can, though I do not have it all figured out, and welcome suggestions and support to improve my course in order to make it more authentic and a reflection of the current reality in Ontario. All right, so we're continuing in Unit 1 today, which is We Are the Guardian of Earth Spheres. We talked about how Earth is a superorganism yesterday and how it contains all of the living and non-living elements that are required for keeping Earth healthy. Yesterday, we looked at the Earth spheres of land, soil, air, and water, and how they're all connected to each other as well as to us and other life forms. So we're going to look a little bit more about the effects on those things and how they change. Yesterday, we just looked at sort of defined them, and today we're going to be looking at the effects of human activity on soil, water, and air. And this is lesson 2 in your workbook. All right, so our learning goals for today are that you will understand the effects of human activity on soil, water, and air. You know that you've met the learning activities because you can explain the impacts of deforestation, urbanization, erosion, chemical fertilizers and pesticides, and industrial chemicals on soil. You can explain how humans create water pollution, and you can explain how the burning of fossil fuels has created the climate crisis and the impacts on humans and the natural environment. So the composition of soil, water, and air usually changes very slowly over thousands of years. Things change, that's normal. Human activities, however, can change soil, water, and air quality in just decades or days. We have a big impact can be really quickly. So these changes can have long-lasting effects on living things, environments, and climate patterns. The effects also impact on our societies and quality of life. They can become permanent before we fully understand the dangers that they pose. So if you think about the video we watched about grassy narrows earlier this week, about how, yes, water composition changes over time, but the dumping of mercury and other chemicals into the English Wabigoon river by the paper mill in Dryden drastically changed the water in an instant. And now, decades and generations later, people of Grassy Narrows are still affected. Animals, plants are still affected by that action that happened in the 60s and the 70s. And it's hard to know if that will ever be able to be reversed. Hopefully, but it's hard to know how much longer it will take till that is actually clean water again. It might never be clean water in the next few generations' lifetimes. So first, let's look at soil. So soil is the foundation of our food. The percentage of Earth's land area that is covered in agriculture use, so 12% of Earth's land area is farmland, 26 is pasture land, so where animals graze, and 26% is forests, so not used for agricultural, and then 36 is unsuited for agriculture or developed. So unsuited for agriculture would be like deserts or like Arctic deserts as well as hot deserts, rock places where there is like the Canadian Shield, which is bedrock, is very close to the surface and there's no real soil on top of it, or it's developed, which means that it is covered by cities and towns and buildings. So only about 38% of Earth's land area is available for either growing crops or grazing animals. Something to be aware of, as food is essential for us. How we take care of that soil is really important. So the global land use for production, how we actually use that land. So Earth's surface, 29% is land, 71% is ocean. Of that 29%, 71% is habitable land. So 10% is glaciers, 19% is barren land, like deserts, salt flats, exposed rock, like I talked about, beaches, dunes, things like that. Then of the 71% that is habitable, so where people have access to and live, 50% of that is agriculture. 37 is forests, 11 is shrub, 1% is urban and built up land, so where we live, and 1% is freshwater, our lakes and our rivers, which is also pretty important to us if you think about it in terms of like, yeah, 71% of the world is ocean, but we can't consume that water. Can't use that water. So then of the 50% of the habitable land that is agriculture, 77% is livestock, so meat and dairy, so grazing land, and 23% are crops. But then if we think about the way that people eat, globally, the amount of food that people eat is 82% come from plant-based food. Most of the energy that people get comes from plants, 82%, but only 23% of our agricultural land is used for growing crops. And then protein supply, 63% is from plant-based food and 37% is from meat and dairy. So that doesn't really line up with the way that we use our agricultural land, with how we worldwide eat. Okay, so that's just thinking about understanding how we use our land, but let's see how the soil actually functions. So topsoil is the most fertile part of soil, and it's found just below the surface of the earth. It's essential for the growth of plants, aka our food and our food's food, right? Animals eat plants, and we either eat plants or animals. So here's a map of Canada, and it's a bit old, but it's what I was able to find. So it's from 2015. And it shows the total number of agricultural operations reporting direct marketing in Canada. So one red dot is equal to about 50 agricultural operations. And then the white area is space that is not good for agriculture, and inside the yellow area is where it is good for agriculture. So you can see that in southern Ontario and Quebec we have lots of agriculture, and then there's some areas sprinkled throughout Ontario and Quebec, and then the Maritimes that is okay for agriculture. And then you can see in the prairies in Alberta, Saskatchewan, and Manitoba, there is an area that is good for agriculture and lots of farms operations. And then in BC as well, you can see in southern areas there's agricultural operations. But you can also see that a large, like significant amount of Canada's land is not suitable for agriculture. And humans are constantly destroying topsoil through deforestation, so cutting down trees that affects the quality of the soil and how the health of the soil, through urbanization. So again, if you think about, if we're looking at this map, this is a population density map, and you can see where there's lots of people. So the brighter the yellow to orange, the more people. So if you think back to that map where I showed where it's good for agriculture, you can see in the same places is where we have all of our population, big population. So, which makes sense, close to the food, but it also means that we are living on that healthy soil and building buildings, which makes it hard to grow food there. Then we have erosion, which is when the nutrients wash away, so either through water or overplanting and how we use that soil, the quality of the soil gets eroded, gets washed away. Chemical fertilizers and pesticides, so the things that we spray on our farming lands, either through big machinery or smaller organizations that spray. Look, if you look how bundled up these people are because they're spraying really toxic things on the food to kill bugs and pests. But really, do we want our food to be covered with, if the people who are putting this on have to look like this, do we really want to be eating that? And then industrial chemicals. So here's a chemical plant, and you can see that the soil is being affected by who knows what, some sort of chemicals as having an impact on the soil. So we do not take very good care of our topsoil, but we can do better. So we can cut forests of ones where logging needs to happen. We need timber that's good health for the forest. It is able to do it sustainably, and they can be reseeded with fast growing plants to help the soil stay healthy. So you can see here are some examples of how soil where logging has happened, where things have been cut out, but that's how the soil is still protected. It's not totally barren and able to be washed away because there's small plants that are helping, their root systems are helping keep the soil healthy. Farms can use various methods to protect their soils. So there's various different ways to plant crops and to aerate your soil in order to protect it. So having windbreakers, meaning like putting up large trees so that the wind just doesn't blow your soil away, planting in strip cropping or contour planting, things not just being lined up directly all the time, having different shelves. There's lots of different ways that farmers can protect their soil. It might not be the most efficient or the fastest way to plant everything because you need to be a little bit more conscientious, but it means that you will be able to invest in a longer period of time because your soil will be healthy longer. Mines can be filled and covered in topsoil and reclaimed. So this is one area of mining. I believe it's in the States, but still we get the picture and it's all related anyway. So here was a mine, and then now covering it up and replanting things means that that soil is protected and can contribute to the ecosystem. It might not be someplace that you want to grow food or something, but it means that it can be healthy for the environment around it. And then polluted soils can be removed and treated. So being conscious about if soil does get polluted, dealing with it instead of just leaving it. So here is an example of excavating contaminated soil and then treating it in order to be able to reintroduce it into an environment. So that's how soil is, human activities impact soil. So there's lots of things that we take for granted and we don't necessarily pay attention to. Now looking at water. So water pollution, lots of activities, human activities pollute the water. And it's quite concerning because if you think back to the fact that 1% of the habitable land, which was 29% of the whole land that we use, is fresh water that we can actually use. The fact that we pollute our water, fresh water as well as salt water, but fresh water specifically, is really quite concerning. So chemical runoffs from mining and pulp mills, like we talked about with the Grassy Narrows example. Linking dump sites. So many of us have, I would assume, have gone to dumps to put our waste, and then it rains on dumps, and then the chemicals run off from, and waste runoff into the soil and into the water. Industrial activities. So just the use of water. Many factories and industrial sites use water to cool things and to manage parts of their activities, and that then pollutes that water. Fracking, which is a method of extracting natural gas from the ground, where they inject water with chemicals into the ground in order to release the natural gas. And so then the water is polluted. And then even recreational activities like boating pollute like using a gas powered boat, the gas runoff goes into the lakes and rivers. Chlorine added to our drinking water to kill bacteria is now linked to hydrocarbons, which are known to cause cancer. So we are adding things that we were hoping, that do kill bacteria, but then are potentially poisoning us as well. And then pavement, concrete, and storm drains funnel rainwater, which is good. It means that it's not flooding our areas, but it runs off of the ground, which collects gasoline, oil, road salt, washing all of these toxins into the closest body of water. So they go into a drainage system, into a sewer system, and then they get pushed into lakes and rivers, as well as all of the contaminants that they picked up along the way. So here is a visual that is in your workbook that just shows you the various ways that water is polluted. So it's not necessarily just people throwing plastic bottles into the lake or something, but there's lots of things. That's not okay, but there's lots of things that contribute to water pollution. So our septic systems leaching into our groundwater, boaters in lakes, our fertilizers and pesticides and manure from agriculture processes, those all leaching into our water. Dumping sites either going directly into water or runoff leaking into our groundwater and our lakes and oceans. Automobiles, gas stations, seepage, all of that goes through, if you think back to the water cycle, things that go into the air then cycle into the water as well. So there's various ways that pollution ends up in our water cycle. So now we have done the questions. You should be prepared to be able to do the key questions on page 12, the check your understanding questions 1 through 4. Okay, now we're looking at air. So fossil fuels. Hopefully this is a term that you've heard before, but let's make sure that we all know what we're talking about. So what are fossil fuels? So coal, oil, and natural gas are all examples of the most common fossil fuels, and they are a source of most of our energy. It's how most of our things function. So let's just look about how coal and oil or petroleum and natural gas were formed so that we understand why they're called fossil fuels. So for coal, an area that was a swamp 300 million years ago, so a long time ago. So this is before dinosaurs, many of giant plants. So there was still ecosystems. They died in swamps, and then Earth changes, things shift, and so things pile on top. So the plants that died were buried underwater and dirt over another couple 100 million years, and then they get compressed and pushed down into this under the soil, under the earth, and the heat and the pressure of being inside of the earth turn this dead plant matter into coal. And so again, this is millions of years that has turned this plants into coal. Then petroleum, so oil and natural gas, are same timeline in terms of 300 to 400 million years ago. In the oceans, there were tiny sea plants and animals. Again, they die, that's natural, and are buried under the soil. Dirt covers them, covered with silt and sand. And then millions of years happens and things continue to pile up. Dirt and water, sand and silt, all and water pile on top of the remains and push them down, and the weight and the pressure of pushing them down and then getting closer to the Earth's core creates heat, and it turns all of the plants and animals' remains into oil and gas. And then now we drill down to those deposits, the oil and gas deposits that were from the plants and animals' remains down underneath sand and silt. So again, this was hundreds of millions of years to make this stuff. This is why they're called fossils fuels, is because they're fuel that we use based on old, dead plants and animals that have been compressed and heated to transform into these sources. And this is also why they are non-renewable, is because it took millions of years for this to happen, for these things to be created. We don't have millions of years to just reproduce. So the burning of fossil fuels, what happens is that many of our activities involve burning those fuels that took millions of years to be developed. So driving our cars, boats, airplanes, heating and cooling our buildings, creating common products. So lots like plastics, lots of things use fossil fuels to create them, and lots of industrial use all burn fossil fuels. So when those things burn those fuels, so burn that coal, oil, and natural gas, the atoms and the elements within those fuels, when they're burned, when the heat is added, they're released. And so the carbon particularly, but nitrogen and oxygen are released into the atmosphere from, so if you think back to what makes up plants and animals, all those elements, when you burn them, they get broken up and they get released into the air, and then they interact with each other, and then they create air pollution. They affect the ozone, they create smog. This is by burning fossil fuels, we're releasing those elements on large amounts into our air, and that changes our air composition. So change needs to happen. This has been a conversation that's been happening for years now, decades, but it needs to happen at multiple levels. So yes, it needs to happen at an individual level. We need to think about how we're driving our cars, how often we're driving our cars, are we taking airplanes, how we are choosing to heat and cool our buildings, our homes. But it also needs to happen at corporation and government levels. There's only so much that each of us as individuals can do. We need to change policy. We need to change practices. So we need to make it so that it is easier and more accessible to not use fossil fuels. As many folks would love to not use fossil fuels. It'd be great if I didn't have to have gas in my car, but I live in a remote area, and in order to survive, I need to drive a car. And so I can't afford to have an electric car. It's not realistic. And so I use fossil fuels. So I can't change that. It's something that the corporations and governments have powers to change those policies. I can influence those policies based on who I vote for and who I support, companies that I support. But it is a bigger picture issue that we all need to do to work together. So interesting. We're now getting a little bit beyond COVID-19 quarantines and things like that. But when in 2019 or 2020, sorry, lots of people started really paying attention once we were quarantined at home. And there were lots of pictures on the internet that were showing the change that once folks were not driving to work as much, were not flying as much, the impact on the air. So here's an image where before 2020, so this is the pollution, this was the smog, this was the air quality. So this dark brownish grainy air was what people were breathing, was what we were all living in. Of course, it's going to be more depending on where you live. If you live in a remote area, it's going to be less potentially, most likely, than if you're living in a highly urbanized, like a big city. But then the second half on the right side picture was during COVID-19 quarantine. So the first one, I would assume, in 2020, like in March 2020. And just after a few weeks, how much the air has cleaned out, how much clearer you can see. This is the same place, this is the same building, right? So just how much cleaner. You can see the leaves on the trees, you can see the individual parts of the building, and it's just so much cleaner just by people not driving to work, and industries shutting down to a certain extent. So it is possible for things to change. We just need to change our ways of living and make it possible for people to survive and function without fossil fuels. All right, we're going to watch a video about acid precipitation, acid rain, which connects all that, the water and the air pollution, all together.
What is acid rain? Acid rain is any form of precipitation with high levels of nitric and sulfuric acids. It can occur in the form of snow, fog, and even dry materials that settle to Earth. Most acid rain is caused by human activities. When people burn fossil fuels, sulfur dioxide and nitrogen oxides are released into the atmosphere. These gases react with water, oxygen, and other substances to form sulfuric and nitric acid. Winds may spread these acidic solutions over hundreds of miles. After it falls to Earth, acid rain enters water systems as runoff and sinks into the ground. This can make water toxic to crayfish, clams, fish, and other aquatic animals. The rest of the food chain, including non-aquatic species such as birds, is often affected as well. Acid rain also harms forests by damaging trees' leaves, robbing the soil of essential nutrients, and making it hard for trees to take up water. By designing cleaner power plants and using fewer fossil fuels, we can reduce the number of pollutants that create acid rain.
All right, so that video just showed us what acid rain is and how it's introduced into our atmosphere. If we think about in our previous lesson where we talked about acidic solutions, so we talked about how water has a pH of 7 and is in the middle of the pH scale, and then acid rain would be more acidic, would have a lower value. And that means that that changes the water composition, it changes the chemical makeup of water, and that affects our animals and our soil significantly. So looking at the climate crisis, which is also thought of, some folks call it global warming, though that term has sort of gone out of favor because it's confusing, and many people say getting warmer isn't bad, it's cold. How is it cold? Global warming can't exist because we still have winter. That's not what it means. So we use the language of climate crisis and opposed to just climate change, because change isn't always bad, but our climate is in a crisis. So looking at global warming, looking at the climate crisis, is that our world is getting warmer. And this is not like a day-to-day, like big temperature change, but overall our Earth is getting warmer. So this graph shows the annual mean land and ocean temperature above or below average from 1850s to 2020. So what this is showing is that, so the whole surface temperature of the Earth we're averaging, so it's going to be different all over the world. So it's combining all that data and making an average, comparing it to the average of what was normal. So is it colder or hotter in the last from 1850 to 2020? And we can see before the 1950s that the temperature was generally colder. So this is between, so the temperature was 0 to -6 degrees Celsius colder than the average temperatures. So we're not talking about we're talking about little amounts, but little amounts have a huge impact. So then since the 1950s, things were kind of balancing in terms of sometimes warmer, sometimes colder, but getting closer to the probably in the 1970s, 1980s, then it started to increase. And now the average temperatures are just getting hotter and hotter and hotter. And now we are over 1 degree. Our average temperature is more than 1 degree Celsius than it used to be. And so this has a huge impact on water temperatures, which has a huge impact on the ecosystems there. So how plants and animals survive, because if things are getting hotter, that is a big change for them. They are very sensitive. And that is also changing our weather patterns as we get more big storms because things are changing. So we get everything is moving and shifting. And so we get big rains, and then big periods of drought are happening, and things like that more and more common. So looking at how that actually means, again, continuing to understand how this affects why it's more than just not having as cold winters, because last year in Sioux Lookout was one of the coldest winters I've ever experienced, where it was like -40 all the time. So the fact that this is why global warming is confusing, is because we still had a really, really cold winter, and it's projected that we're going to have another really, really cold winter here. And so it's not that everything is getting warmer, it's that patterns are changing. So remembering that from 1850s to 1900s, we're sort of at a average temperature, we're comparing to that time. So at 1 degree warmer than that time, you can start to see that how things change, how things are getting affected. Things are getting warmer in different areas. And at 1.5 degrees Celsius of global warming, so we're starting to get more red. Things are just shifting. At 2 degrees Celsius warming, all of a sudden we're getting super, super dark. This is how much we're actually changing in the actual temperature in those areas. And at 4 degrees of global warming, we're over 7 degrees hotter in those areas. And so most of Canada is going to change, and that's going to change the climate of what we can grow. It's going to change our soil composition. It's going to change our forests. It's going to change for the animals. Everything's going to change. It's changing our glaciers. It's changing our water. Sea levels are rising because our glaciers are melting because it is hotter. And so then we're losing landmass because our sea levels are rising. So there are lots of domino effects of the impacts of the whole earth getting warmer, more beyond, like, other than just it feeling warmer. It's much more complicated than that. So how did this actually happen? How did the climate crisis arise? So we talk about greenhouse gases, so GHGs is sometimes in short. And so we have our atmosphere around our earth, right? Keeps our oxygen in, keeps it so that we don't float away, but also means that we can breathe. So the sun comes in and that heat gets bounced out, and some of it gets bounced back and keeps us warm. It means that we can survive, and some of it escapes. Most of the heat escapes into the atmosphere. Is able to go through the greenhouse gases, the carbon dioxide, that's nitrogen oxide, carbon, hydrocarbons that are all in our atmosphere, that's all naturally there. The sun heat can still go out. But what has happened as we release more and more carbon dioxide and hydrocarbons and nitrogen oxides into the environment, into the atmosphere, it means that the solar radiation, the sunlight that comes in and the heat that comes in, is getting trapped. It cannot get out into space. And so it's bouncing back and heating up the earth. Because if you think about being in a greenhouse, or when your car is in the sun and you come into your car and it's chilly outside, but then you get into your car and your car's really warm because the heat has been trapped by the glass inside, and so it's warmed up. So the same idea is happening, is that the atmosphere is getting thicker with all of these pollutants, all of these elements, compounds, and they are trapping the heat from the sun, which means that things are getting warmer on the earth, which then has that impact that we were just talking about. So what again does that going to mean directly? So how does that impact humans? So if the temperature rises cannot be kept within 1.5 degrees Celsius, which we're already pretty close, the UK and Europe will be vulnerable to flooding caused by extreme rainfall. Countries in the Middle East will experience extreme heat waves, and farmland could turn to desert. Island nations in the Pacific region could disappear under rising seas. So whole islands will just vanish where people are currently living. Many African nations will likely suffer droughts and food shortages. Drought conditions are likely in the western US and Canada, while other areas will see more intense storms. Australia is likely to suffer extreme heat and drought. So some of these things are already happening. You can already think of news stories of where like Australia is being on fire, and already heat waves and extreme intense storms. All of those things are already happening. So the impacts on the natural environment, not just the human environment. So the Great Barrier Reef in Australia has already lost half of its corals since 1995 due to warmer seas. So that change in the water temperature has killed off half the corals, which is a large way, like the health of the oceans has an impact on our air quality and things like that. Wildfires are becoming more frequent as climate change increases the risk of hot, dry weather, which we've experienced both. We can think of the big fires in Australia, but also in Canada, there's been lots of fires this summer. We had a wet, cool winter. Summer was wet and cool. So we didn't have as many fires this year, but in the previous few summers, we've had lots of fires. As frozen ground melts in places like Siberia, greenhouse gases trapped for centuries will be released in the atmosphere, worsening climate change. So there's carbon already trapped in those, like that water that's frozen and the ground that's frozen. There's compounds trapped in there. So if those are getting released, that's going to contribute. It's going to escalate this issue as more. And animals are finding it harder to find food and water. So polar bears are known, they're dying out as ice that they rely on or melts away. And elephants are struggling to find water. They need so much water and they're having a hard time finding it every day. So scientists believe that at least 550 species could be lost this century. Once we lose animals, they're never coming back. So now you can answer the key questions on page 15, the check and understand questions 1 through 3. All right, and that is what we were covering today in terms of the impacts on the effects of human activities on soil, water, and air for lesson 2. So recap, soil, we talked about deforestation, urbanization, erosion, chemical fertilizers and pesticides, industrial chemicals, and how they all destroy the soil. We talked about water and how recreational, industrial, and everyday human activities pollute our water. We talked about air and how the burning of fossil fuels leads to air pollution and the greenhouse gases effect, which is leading to the climate crisis, resulting in detrimental effects to both humans and the natural world. So the success criteria, knowing that you've covered, that you understand what we were talking about today, is that you can explain the impacts of deforestation, urbanization, erosion, chemical fertilizers, pesticides, and industrial chemicals on the soil. You can explain how humans create water pollution, and you can explain how the burning of fossil fuels has created the climate crisis and what the impacts are on humans and the natural environment. If you can do all of those things, then you've been successful in today's lesson. So now you can do the review questions on page 17, questions 1 through 11. A reminder again that you can write in your workbook, but that I encourage you not to, just because the space is often, it's very small and it's hard to explain all of your thoughts there. All right, if you have any questions or concerns, you're unsure about anything, please reach out and contact me. I am reaching out to students, but it takes me a little bit of time. So if you are waiting for me, please reach out. You can call me at the office at 807-737-1488, extension 2209, or toll free at 1-800-667-3703. My email address is bronwyn.slate, and that's spelled BRONWYN.SLATE@nnec.on.ca. You can connect with me through Facebook at Slate Wahsa, and also go to YouTube where you can watch these videos as well as all the supplementary videos of our class, where my channel is Slate Wahsa as well. My hours are Monday through Friday, 8 a.m. till 2 p.m. So if you want to reach out to me directly, then that is the best time to get a hold of me, though I am available to discuss with you other times, alternative times, if you need to connect with me and that timeline doesn't work. Just reach out to me and we can make a plan. Thank you so much for joining me. I hope you have a lovely day and a lovely weekend, and we will see you next week. Miigwech.